All right, everybody, welcome to the video here for our factoring completely lesson. So when we're factoring trinomials, we want to make sure that we're looking for a GCF first. So number one, I see 6, 48, and 90 definitely has a GCF. There's a GCF there of 3. So if I divide out 3, I'm left with 2x squared plus 16x plus 30. Actually, there's a bigger GCF than that. 6 actually goes into all of those. So let's see. So I can divide out 6. That gives me x squared plus 8x plus 15. So then if I factor that, I'm figuring out what multiplies to make 15, but adds to make 8. So that's going to be x plus 5, x plus 3. Number 2 is where we have to first use the AC method. So we're going to multiply 3 times negative 20. That's going to be negative 60. And we want to add to positive 4. So what two numbers make that work? So 10 and 6, so we can make it a positive 10 and a negative 6. So then we're going to break this up. 3x squared plus 10x minus 6x minus 20. GCF of the first two terms is x, leaving us 3x plus 10. GCF of the second two is negative 2, which would be 3x plus 10 also. That factors to x minus 2, 3x plus 10. For number 3, AC method again. So it multiplies negative 66, adds to make 5. So that would be 11 and negative 6. I'm going to break this up. 2x squared plus 11x minus 6x minus 33. GCF of the first two is x, leaving with 2x plus 11, negative 2, no, negative 3, giving me 2x plus 11. Again, these two parentheses should match each other. So then I have x minus 3, 2x plus 11. Doesn't matter which one you put first. Last one here is the GCF of x, which gives us 5x squared minus 41x plus 8. Multiply the a and c together. You get 40. Add to negative 41. So that's going to be 5x squared minus 40x minus x plus 8. Don't forget about the x. That's the GCF. Break this apart. So the breaking apart is going to give me a GCF of 5x, giving me x minus 8, negative 1, x minus 8. We take out the negative 1 there to get us a favorable sign. So our final answer here is going to be x, 5x minus 1, and x minus 8. Number 5 says Victoria was factoring the polynomial. She noticed that there was no GCF, and she believes that that is the correct factorization. Does this factoring have a GCF? The answer is no. There's no GCF in this factoring. 2, 13, and 20 have nothing in common. But she did make a mistake. If you were to quickly multiply that back out, what Victoria has there, 2x and 4, and x and 5, you get 2x squared, 10x, 4x, and 20. The first and last terms are good, but this middle term only adds to 14x. I want it to add to 13x. So to fix Victoria's mistake, I have to figure out what multiplies to make 40, but adds to make 13. So that's going to be 8 and 5. So I'm going to do 2x squared plus 8x plus 5x plus 20. Do my little GCF thing. And we can see that she has the right numbers, she just has them in the wrong spot. Another red flag that she's factored wrong here is there's still a GCF here, but there wasn't one in the original problem. Next says, Julie claims that this polynomial is equivalent to these two factors. Is she correct? You can just multiply it out. So we're going to get 6x squared minus 4x plus 15x minus 10. Combine your like terms, and she is correct. All right, we just distributed there, or you can use your boxes, however you want to do it, your choice. Next one, here's the graph of a polynomial, right? We have a perfect square polynomial here. It says state the domain and range. The domain is the possible x values. So my smallest x value is -1, 2, 3, 4, and it goes on forever. So I would say this is going to be starting at -4 and going to infinity. State the range of the function. Range of the y values. The first y value we come in contact with is 0, and this also goes up forever. We'll start talking about graphs in this unit in the next few units as well. For the next one, we're asked to find the quotient. We haven't done this in a few lessons, so I would put -3/2 in the jail. I have a 4, a 0, a 5, and a 21. The 4 comes down. -3/2 times 4 is just -6. -6 comes down. -3/2 times -6 is positive. So we're going to get a +9. That's going to give us a 14. -3/2 times 14 is -21, which gives us a remainder of nothing. Remember, whatever the denominator is, we got to divide all that by it. So our numbers are really 2, -3, and 7. So my answer is 2x squared minus 3x plus 7. Factor the expression completely. I see a GCF of 2x, leaving us with x cubed minus 8. That's going to be the difference of two perfect cubes. So that's going to be x minus 2, x squared plus 2x plus 4. Remember, the signs kind of just go in the order of SOAP. And just remember you're squaring that first and last term. Last one also says factor completely. GCF there is 2, leaving us with 3y squared plus y minus 80. Multiply 3 and -80 together, and we get -240. And we want to add to 1. So numbers that multiply together to make -240 would add to make 1. So we're going to wind up getting a +16 and a -15. So we can break that apart. Remember, the 2 just hangs out. So I have 3y squared plus 16y minus 15y minus 80. GCFs, no GCF between 3 and 16, so just y. 3y plus 16. GCF here is 5, so -5. 3y plus 16. So my final answer is 2, y minus 5, 3y plus 16. There's your final answer. Hopefully this video helped. See you tomorrow.